apparently. Okay, good morning, calculus lovelies. If you'll notice, the facial hair has changed a little bit. It's the end of No Shave November, so it is now sculpted into something lovely. But what we have to do is we have to talk about the derivative of inverse functions. So what I'd like you to do is I'd like you to take out those notes, and I would like you to go to this section that has this little kind of square, and it asks you to do a problem. So what I'd like you to do is I would like you to stop the video right now, and I'd like you to work through A through D. Okay, I'm assuming you stopped the video and you worked through A through D, but now I'd like to kind of go through those with you. So the first thing it says is graph the line of 2x plus 1. So if you remember from algebra, you go to 1, and then it's up 2 over 1, up 2 over 1, and then down to back 1, down to back 1, down to back 1, and you draw your line. Not spending a lot of time reviewing how to graph lines. Okay, so it says, what is the slope of that line? Well, the slope is 2. Okay, now it says find the inverse function and graph it. So if you remember, to find the inverse function, you need to switch the x and y and then solve for y. So I'm going to show you kind of the work right down here. So we're going to switch the x and the y. So I'm going to say x equals 2y plus 1. And then now we just go through and solve for y. So I'm going to move the 1 to the other side. So that's going to be x minus 1 equals 2y. And I just realized I forgot to present my window again. So good thing we caught it soon enough. So take a look at what I've done thus far. So again, we graphed the line, went to 1, and then up 2 over 1, up 2 over 1. And we graphed our line. And again, the slope is 2. And then find the inverse of a function and graph it. So you switch the x and the y and solve for y. So what I'm doing right now is I'm solving for y. So we have x equals 2y plus 1. Subtract 1 to the other side, and then divide everything by 2. So you get y equals 1/2 x minus 1/2. Now they want us to graph this. So let's start at -1/2. And then we go up 1 and over 2, because our slope is 1 over 2. So we go up 1 and over 2. And we go down 1 and back 2. Down 1 and back 2. And now we have this line that goes right through here. So this is y equals 1/2 x minus 1/2. This is the inverse. Okay, so what do you notice? Well, what is the slope of the inverse? Well, the slope of the inverse is 1/2. It says if 2,5 is on the original line, okay, so 2,5 is right up here. What is its corresponding point on the inverse? Well, remember, inverse functions are always reflected over the line y equals x. So if we go straight across this line to its corresponding point is 5, 2. So what is the connection between a original function and its inverse? Well, the slope of the line at 2,5 on the original function is the reciprocal of the slope of the inverse. The difference is the inverse is calculated using the point 5, 2 instead of 2,5. So let's go through and let's talk about how we're going to use this. So we're going to use this idea to find, there's 2 different ways to find the derivatives of inverses. The first way is kind of what we did in part B up here in this problem. So the key thing here that you have to do is you kind of look through these 4 steps. The first thing is you need to find the point. you're only given one coordinate. Okay? If you're only given one coordinate, you got to substitute it into the original function and find the point. But remember, an x value on the inverse is the y value on the original. So that's going to be really important. Now, the second thing you do is find the inverse point. It is very important that you know your 2 points. What is your original point and what is your inverse point? Then, just like we did in B, interchange your x and y, and then derive implicitly. Okay? Then substitute your inverse point into the equation and solve for dy dx. Okay? So I'm going to show you how to do this in a different problem. Now, the other thing, there is one other method before we even start to try to do some problems, and that other method kind of looks like this. It's more of a connection. Okay? The other method is just using some properties of derivatives and inverses. So the thing I would like you to note is I would like you to note what it's kind of saying on this side. So first of all, we have this little piece right here. What that says is that says the derivative of the inverse. Okay? And then in this part right here is at x equals p. And notice p is the x coordinate of the original point. Now, on the other side, it's equal to, over here, the reciprocal of the derivative at x equals q. And notice that that is the y coordinate of the original point. So remember, there's that connection between the original point and the inverse point. It's literally switching the x's and your y's. So we're going to use these two pieces of information to solve some problems. So first of all, let's take a look at this first one. So I'm going to do the first problem, and then I'll have you guys and then I'll do the second problem as well, and then you guys will go through and have to apply this in a little bit. So first thing you have to do is there's always a couple things you have to find. So with the first method is the first thing you should always find is find your original and inverse points. Okay? And I like to kind of split these things up. I like to split it up into the original, and inverse material. Okay? So let's kind of read the problem and let's see what our original point is. So it says, let f of x equal this. Find the derivative of the inverse. That's what this says. At x equals -1 at the point 0, 1 using both methods. Okay, or 0, -1. So our original point is 0, -1. Now, what does that mean our inverse point is? Well, our inverse point then is -1, 0. Notice that the x and y's have switched. So in the original, this is your x and this is your y. On the inverse, the -1 is your x and the 0 now is your y. Okay? So keep that in mind when we're going through and working this problem. So method 1. If you're going to do method 1 is the interchange method. And what that means is that simply means you are going to interchange your x's and y's and then derive it implicitly. Okay? So let's go through and let's start with our original equation. We have y equals x to the 5th plus 2x minus 1. So now the first thing you do is you just interchange your x's and your y's. So we're going to go x equals y to the 5th plus 2y minus 1. So now once you do that and you interchange them, now take your derivative with respects to x. So we are going to do, of course, the d over dx. So let's take the derivative of each of these pieces. So the derivative of x is 1. The derivative of y to the 5th. Remember, anytime you derive implicitly, it's going to be 5y to the 4th times, and I'm going to use y prime because it's easier to write out. Go to 2y. The derivative of 2y is going to be plus 2, but remember, you have to multiply by y prime. And then, of course, the derivative of -1 is 0. Okay, so now let's go through and let's solve for y prime. So what I'm going to do is I am going to solve for y prime. So I'm going to take out my y prime, and it's going to be multiplied by 5y to the 4th plus 2. So y prime equals 1 over 5y to the 4th plus 2. And when we go ahead and do that, our y prime, or our y value in the original, so we're using the original stuff here, okay, is, actually, nope, we're using our inverse, we're using the 0, okay? So we use our inverse point, and remember our inverse point has a y value of 0, so plug that in. Y prime equals 1 over 5 times 0 to the 4th plus 2. So y prime equals 1/2. So our slope at the inverse point is 1/2. So these are kind of your steps. Interchange your x and y's. Take your derivative with respects to x. Solve for y prime. And then use your inverse point and plug in the values to find the slope. 1, 2, 3, 4.